Hi, it's Mrs. Michael. It's a gorgeous day today. We're going to be launching a mid-altitude balloon today. So you may be wondering what a mid-altitude balloon is or how we can track it or anything like that. So let's run through a couple basics before we get started. This is a transmitter that we're going to be using for a balloon. We use something called an APRS system. APRS is short for Automated Packet Reporting System, and it uses ham radio to be able to transmit a signal. So you heard the APRS for the packet. So what happens in this transmitter is it has a little packet of information. It sends up to a satellite, and then if you have a ham radio call sign, you can pick up where that packet of information is, just kind of like a GPS on your car. You'll see that it has two solar panels on it. The two solar panels give the transmitter its power. So because it's a solar panel, it doesn't work at night. So we say that it goes to sleep once the sun goes down, and it wakes up when the sun comes up. It's still moving, we just can't track it. You'll see for this particular transmitter, it's got some really, really thin wires. We call them dipole, di meaning two. So when this is hooked up, then the two poles are going to be just sort of sifting out like this. So now that we've talked about the transmitter, let's talk about the balloon. So today we're going to be using something called a double Mylar launch. So Mylar for Mylar balloon, double for two of them. So this balloon is a lot like a party balloon, but as you'll quickly see, it's not quite. So this is our balloon. This is not the exact balloon that we'll be using. We have another one that we have set up. But so this Mylar is 36 inches across. Most of our party balloons are about 18 inches, so it's about twice the size. We're doing a double Mylar, which means we're gonna be filling two balloons at the same time. We're gonna have them attached, so then that way it gives a little bit more stability to the transmitter. And our goal is for it to go around the world. Now I know some of you guys are thinking, oh no, but we have balloons, and balloons are dangerous for the environment, and balloons are dangerous and they could get into power lines, and you are definitely correct. I agree with you. However, when we do this, first of all, we check all of the weather conditions. So we do not launch when it is dangerous. We do not launch when it is windy. As you can see behind me, it is a gorgeous morning. Yes, what does come up does come down. So eventually the balloon will come down. However, we take all of our proper precautions, and we are doing a lot of science with this. We're doing a lot of investigating, a lot of research. We're not simply throwing a balloon into the air and waving bye-bye to it and it just drifts off. We're actually actively tracking it. We're doing it for science. So yes, I understand your concerns. I'm with you. I completely support you. And whenever possible, we do try to retrieve it. Most of the time it actually ends up going around the world, and we can't really, but we do have on all of our transmitters, we have our call signs, we have an email address, and so we do try to actually get it back so we don't have these into our oceans and into our trees and things like that whenever possible. So when we're filling a balloon, we do have two different kinds of gases that we can use. We can use hydrogen or we can use helium. Both of them have advantages and disadvantages. Today, because we don't have any students with us because of COVID, we will be using hydrogen. Hydrogen, as you can imagine, is a little bit more dangerous, but it is also a lot more sturdy and reliable in terms of what we're using it for today. So we'll be using proper precautions. We have proper ventilation. We are trained in this, and I think we're going to have a fantastic launch. So I'll be taking some pictures of us filling the balloons, and then we will be recording the launch, and then you'll be able to track with us. Stay tuned. Okay, so we're going to launch one of the tester balloons. This is just to see where the wind is, to see if we need to move our positioning. So whenever you're ready. So even though it looks like we're just throwing a balloon in the air, we're actually tracking exactly where it is. We're seeing which direction it's going, if there's any good wind bursts at any different altitudes, things like that. It's looking like it's going pretty straight up. It's not really pushing to one direction or another. It's going in a pretty straight path. So what that tells us is that we don't need to change our launch location. Okay, we're gonna let it go. Should I let it go? I feel like I'm flying a kite.
Can you stand closer to the edge so that it doesn't bang into the...
Yes.
Yep.
On your mark.
Yes, 5, 4, 3, 2, 1, let it go.
So the balloon's now up in the air. Isn't that exciting? But you may still have some questions. Like, I have a feeling most of you guys were wondering why the balloon wasn't all the way full. And why did we have those scales and things like that? So when we fill our balloons, we don't fill them all the way. We put in just the right amount of gas, so just the right amount of hydrogen to have it hit what we call neutral buoyancy at about 30,000 feet. So neutral buoyancy is when the outside pressure is the same as the inside pressure. So the gas can't expand anymore and it can't shrink down anymore, so it doesn't go up any higher or any lower, and it just sort of stays there. So we want that to happen at about 30,000 feet. 30,000 feet is the layer of the jet stream. And the jet stream is a big band of air that travels across the country, and it goes really, really fast. It goes hundreds of miles an hour. When you go on an airplane, the airplanes get up to cruising altitude, which is in the jet stream, which helps them go really fast across the country. So if you've ever flown across a country, you may have noticed that you can go really fast one direction, but then when you go the other direction, it seems to take a lot longer and it might be a little bit bumpier. The reason why it's bumpier is because you're going against the jet stream. You're going against that band of air that's moving really, really fast. So when we do our mid-altitude launches, we want our balloon to get right into that jet stream so that it can go flying across the country. So what's even more fun is the jet stream goes all the way around the world, but it changes. It doesn't go in a straight line. It dips up and down and it sort of swirls around a little bit. So part of the reason why we were so excited to launch today is because the jet stream is in a great spot for us to be able to go across the country. So some of you guys may also be wondering, wait a minute, if we want this balloon to be going right in the spot where airplanes are, isn't that dangerous for airplanes? Can't the airplanes get hit by the balloons and it could cause a problem? No. These balloons are too small to be affected by the airplanes. And because they're used Mylar, because they're super shiny, the pilots can see them. When we do the big balloon launches, the high altitude launches, we contact the air traffic control towers and things like that, and we let them know. And I do let the traffic controllers know around just to be on the safe side. But no, this is not going to affect the airplanes in any way, shape, or form. It's too small. The transmitter itself only weighs 12 grams, which is less than a quarter. So we don't have to worry about it. So what's happening now is our balloon is still going up to cruising altitude. You can track it on aprs.fi. And in that little box where it says track call sign, it's in the upper right-hand corner. You put in KM6 BWB-1. And you can track it. You can track it all day long until the sun goes down. And then when you wake up in the morning, you can make your prediction on where you think it will be and then see if you're right. But remember, if it changes into a different time zone, it may go to sleep before we're ready to go to sleep. So we'll see. But I hope you enjoyed watching and tracking the launch.